TransAlta is a company that's been around for 115 years in the power generation. We have a unit that was built in 1941, steel riveted penstock, showing signs of decay.
Organizing a routine penstock inspection in 2019. We gathered a ropes crew, the NDE technicians went into the penstock, and we found thin sections that required further review.
And we found that there was more corrosion than would meet the requirements for withstanding the surge pressures of the penstock. So we believed that the penstock was reaching the end of its service life and it had to be remediated. We looked at multiple options to remediate the penstock. Most of those included coating the penstock, either with an epoxy or a polyurethane liner, replacing the penstock, or doing a carbon fiber lining of the penstock. And each of those had its advantages and disadvantages.
So FRP came in at the right spot to match our needs. So between the scored criteria and fit-for-purpose nature of the FRP, that's the technical option we selected for mitigating the Cascade penstock.
So the scope of work of this project is to rehabilitate the 96-inch diameter penstock pipe. It's approximately 460 lineal feet, and we are installing a carbon fiber reinforced polymer CFRP system throughout the entire 460 lineal feet of the penstock piping.
We're cognizant that the Cascade penstock is located in the National Park. It's located near critical infrastructure, including the Trans-Canada Highway, including the Trans-Canada Rail system. So protecting that environment and protecting surrounding infrastructure and respecting surrounding stakeholders is important to TransAlta.
We've never done a project of this magnitude with this amount of lineal footage that's on an incline, with the majority of the slope being on a 30-degree angle. One of the bigger challenges on the front end was figuring out how we were going to abrasive blast the inside of this penstock, partnering with some team members from our structural technologies research and development team. We were able to utilize a robotic blast cart to be able to complete a majority of the required surface prep, all while limiting the amount of manned entry inside of the pipe.
There are some innovative choices for this project. Being on a 30-degree slope, Pullman installed a stair system and a cart system for workers to work efficiently and safely within the penstock, and a cart system to efficiently and safely pass supplies back and forth.
Once we got rolling, we got to utilize the cart, which was very cool, and I think a company first for us here, utilizing something of that nature. Using it to get the stairs in was a very helpful, useful tool. Once we got them down there, it was really about staying tied off and just hard physical labor, lining everything up, getting those bolts installed.
The safest, most quality way to do this project was to have the staircase. However, this presents challenges that now we have touch points where we intend to install carbon fiber. Because of that, that means there's a lot of getting ahead in certain areas and then we'll say falling behind in where the touch points are.
For this project, quality control is a little extensive. We have 2 full-time Pullman personnel that is solely responsible for the quality reporting of this project. We also have an owner-supplied engineer that is full-time on this project that is doing the quality assurance.
To date, we've logged approximately 9,000 man-hours and have 0 incidents or OSHA reportables.
There's cohesiveness that's apparent when in the penstock. The crew works together well, shows competence. So during the actual placement of the FRP, I think that's where we've really seen an acceleration and been impressed by how Pullman's executing the work. A lot of work done ahead of schedule. In general, the project's ahead of schedule.
There's a lot of aging infrastructure across the world, and a lot of old pipes like this that were laid in the 40s, the 50s, the 60s are starting to reach the end of their service life. And CFRP, I think, is probably going to be a solution that comes up more and more often.
Unfortunately, but maybe fortunately for Pullman, we have other vintages of penstocks and aging penstocks, which we'll have to make similar decisions and options assessment. Been impressed by Pullman's work. So the ability for FRP to strengthen the penstock from the inside and avoid a lot of the environmental impacts that would be involved with digging up a penstock and replacing it with a steel penstock, those factors are very appealing for FRP, and Pullman, again, their performance has spoken for itself.